Proving angles congruent. Objectives: to prove and apply theorems about angles. Vertical angles. Vertical angles are congruent. That means that angle 2 is congruent to angle 4, and angle 1 is congruent to angle 3. Okay, notice we have vertical angles here. We have angle 1, 2, 3, and 4. Go hogs. So now I'm going to fold on that line. I'm going to fold so that if you look at this, what you see on one side, you see on the other. Notice it doesn't bleed through, and it's because angle 3 is right on top of angle 1. You can try this at home. Take a piece of paper, make an X, and fold it down the middle, and you can get your angle 1 and 3 to line up on each other. Same thing with angles 2 and 4, and it's because vertical angles are congruent. Vertical angle proof. It says, given that angle 1 and angle 3 are vertical angles, prove that angle 1 is congruent to angle 3. Okay, first, we want to start off with the given information. Now, almost all proofs start off with the given information, and that's to say that angle 1 and angle 3 are vertical angles. And that was given. Okay, then we need to say that we know that if we add angle 1 plus angle 2, or angle 1 and angle 2 right here, form a straight line, so they're a linear pair. But angle 2 and angle 3 are also form a linear pair. So let's see, to write that down, we would say angle 1 and angle, that's an and, 2 are linear pairs. And angle 2 and angle 3 are also linear pairs. Well, how did I know they were a linear pair? Well, it's because they form a straight line, and so we would say definition of a linear pair. Okay, now that we know that they're linear, to know that they're linear means they form a straight line. If they form a straight line, that means they add up to equal 180 because linear pairs are supplementary. So I'm going to say that angle 1 plus angle 2 equals 180. And angle 2 plus angle 3 also equals 180. And it's because linear pairs are supplementary. Okay, now that we know that they equal the same thing, I can say that angle 1 plus angle 2 is equal to angle 2 plus angle 3. And that's by substitution because I'm replacing the 180 here with this part right here. So by substitution. Okay, now we're going to do some algebra. I want to prove that angle 1 is congruent to angle 3. So to do that, I'm going to subtract angle 2 from both sides, which would leave me with angle 1 is equal to angle 3. And this is by subtraction, because I subtracted angle 2 from both sides. And then I can finally say that angle 1 is congruent to angle 3 by the definition of congruence. Example 1, it says, what is the value of x? Now notice here we have vertical angles, and since we have vertical angles, I know that this angle is congruent to this angle. So I can say 3x equals 2x plus 40. I'm going to solve for x, so I'm going to subtract 2x from both sides. and I get x equals 40. And since it just asked for the value of x, I'm done. Example 2 says, use the vertical angle theorem to prove the following. If it's given that angle 1 is congruent to angle 2, prove that angle 1 is congruent to angle 2, is congruent to angle 3, is congruent to angle 4. Okay. Well, I'm going to start off with my given information. Statements, reasons. Angle 1 is congruent to angle 2. That was given. Now, if I look at this, if I know 1 is congruent to angle 2, I know by vertical angles that angle 1 is also congruent to angle 3. I know again by vertical angles that angle 2 is congruent to angle 4, and therefore, since the angle 1 was equal to angle 2, they're all going to have to be equal to each other. But we have to put this in a proof. So I'm going to start off with saying that I know they're vertical angles. I'm going to say angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4 by the definition of vertical angles. So I'm just going to write vertical angles congruent. Okay, so then I can say that angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. Now I know this because if I knew in the beginning that 1 was congruent to 2 and 2 is congruent to 4, then 1 has to be congruent to 4. And that's by the transitive property. Okay, and the same thing goes for the other as well. So like if I know that angle 1 is congruent to angle 2, and I know that angle 1 is congruent to angle 3, then that means 2 is congruent to 3. And then finally I can say that angle 1 is congruent to angle 2, is congruent to angle 3, is congruent to angle 4, and again this is by the transitive property. Part B says, how can you prove that the angles are congruent to each other without using the vertical angle theorem? Explain. The other thing you could do is you could talk about supplementary angles or linear pairs, because if we know that angle 1 and 2 are congruent to each other, we know that they form a right angle. Well, if they form a right angle, then 1 and 2 are right angles. Well, 2 and 3 would also be a linear pair. That equals 90, meaning that 3 has to equal 90 degrees. And the same thing, 3 and 4 then also has to equal, 3 is 90 degrees, meaning 4 has to equal 90 degrees. And that's another way you could have went about proving that all 4 angles are congruent to each other. Congruent supplements theorem. Paragraph proof is written as a sentence, or written as sentences in a paragraph. It says theorem, congruent supplement theorem says if 2 angles are supplements of the same angle or congruent angles, then the 2 angles are congruent. Now what they mean by that is, let's say we can see that these guys are supplementary. And let's say I have another angle right here. If I know that 3 is supplementary to angle 1, that means that angle 2 has to be congruent to angle 3, because they have to add up to both equal 180. And if we're not changing one of the numbers, like angle 1, then that means that 2 and 3 have to be congruent to each other. Okay. The paragraph proof. We've already proven this with a 2-column proof, but it says, given that angle 1 and 3 are vertical angles, prove that angle 1 is congruent to angle 3. It says it's given that angle 1 and angle 3 are vertical angles. The diagram shows that angle 1 and angle 2 form a linear pair. The diagram also shows that angle 2 and angle 3 form a linear pair. By definition of a linear pair, angle 1 plus angle 2 has to equal 180, and angle 2 plus angle 3 has to equal 180. By the transitive property, angle 1 plus angle 2 That shouldn't be by transitive. That should be by substitution, sorry. By the substitution property, angle 1 plus angle 2 is equal to angle 2 plus angle 3. Then by the subtraction property of equality, we can subtract angle 2 from both sides, resulting in that angle 1 is equal to angle 3. And finally, angle 1 is congruent to angle 3 because equal angles are congruent. So basically, it's taking what we did in our two-column proof and putting it in sentences. Theorems. The theorem of congruent complements, this is the same as our supplementaries that says if two angles are complementary to the same angle or congruent angles, then the two angles are congruent. So basically saying if angle 1 and 2 here are complements, meaning they add up to equal 90, and angle 2 and 3 are complements, then angle 1 and 3 have to be congruent to each other. We know that also that all right angles are congruent. That's a, well, no kidding moment, but it is stated that in a theorem that we know that all right angles are congruent to each other. And it says in the last one says if two angles are congruent and supplementary, then each form a right angle. And we already seen that in the previous proof when we proved that all four angles were congruent to each other. Okay, lesson check. Try to complete these questions before you come to class, and then we'll go over them in class together.